Artificial intelligence could lead to a surge in e-waste. The widespread adoption of artificial intelligence, AI, is expected to accelerate technological obsolescence, which will result in a significant increase in e-waste, potentially reaching up to 5 million tons by 2030. As AI continues to develop and becomes more integrated into various industries, the rapid pace of technological advancements will render existing devices and systems outdated at an increasingly fast rate. This will lead to a massive surge in discarded equipment, placing additional strain on the environment and creating new challenges for waste management. The rapid turnover of electronic devices, from smartphones to servers used in data centers, will contribute significantly to this e-waste crisis. As AI algorithms evolve and require more processing power, older hardware will no longer meet the demands of modern systems. Consequently, businesses, governments, and consumers will be faced with the dilemma of what to do with their outdated technology. Much of this discarded equipment will end up in landfills or incinerators, contributing to pollution, resource depletion, and environmental degradation. The growing volume of e-waste raises critical concerns about the environmental impact of its disposal. Electronics contain hazardous substances such as lead, mercury, and cadmium, which can leach into soil and groundwater if not properly handled. The improper disposal of electronic devices can also release toxic gases into the atmosphere, further exacerbating air pollution. Additionally, many of the valuable components in electronic devices, such as precious metals and rare earth elements, are wasted if not properly recycled. Experts warn that the rapid pace of technological advancement, driven by AI, is likely to intensify the e-waste crisis unless proactive measures are taken. One of the key solutions is for manufacturers and operators of AI technologies to adopt a more responsible approach to electronics production and disposal. This includes focusing on the recycling and reuse of components, which can significantly reduce the volume of e-waste. By designing products with modular parts that are easy to repair and upgrade, manufacturers can extend the lifespan of devices and reduce the need for replacements. A more circular approach to electronics manufacturing would also enable the recovery of valuable materials, such as gold, silver, copper, and rare earth metals, which are often used in the production of electronic devices. These materials can be extracted from discarded devices and reused in the creation of new products, reducing the demand for raw materials and lowering the environmental impact of mining operations. In fact, research shows that recycling electronics could reduce e-waste by as much as 86%, making it a vital strategy for mitigating the environmental impact of AI-driven technological progress. Another important consideration is extending the support for older operating systems and devices. While the pressure to keep up with the latest AI advancements may encourage businesses and consumers to upgrade their equipment frequently, there is potential to reduce e-waste by maintaining and supporting older systems for longer periods. This could help to prevent the premature disposal of functioning equipment and keep devices in use for longer, reducing the volume of electronic waste generated. Governments and regulatory bodies also have a crucial role to play in addressing the e-waste crisis. They can introduce stricter regulations on the disposal of electronics and incentivize recycling programs. By implementing extended producer responsibility (EPR) programs, where manufacturers are held accountable for the entire life cycle of their products, governments can encourage companies to take responsibility for the end-of-life management of their devices. Additionally, the development of efficient e-waste collection and recycling infrastructure is essential to ensuring that discarded electronics are properly processed and their valuable materials are recovered. While AI holds tremendous potential to transform industries and improve our lives, it also brings with it significant environmental challenges. To mitigate the negative impact of AI-driven technological obsolescence, it is essential that manufacturers, consumers, and governments work together to adopt responsible practices in electronics production, recycling, and disposal. By taking proactive steps to reduce e-waste, we can ensure that the benefits of AI are not overshadowed by the environmental costs.